So here we're going to determine the equation of a polynomial with certain characteristics here. In this particular one, it says it has two zeros, one at x equals 0 and one at x equals 3, but it has a degree of 4, and also that it starts down. So there's a lot going on here. It seems kind of complicated at first, but we're going to break it down and see that it's not so bad. So if the polynomial has, we're going to really work backwards here. If the polynomial has zeros or x-intercepts at 0 and x equals 3, the factors must look like this. So remember, we set it equal to 0 to find the zeros, so this would be it. This would have a 0 of x equals 0 right here, and x equals 3 right here. But we need it to have degree 4. The way I have it drawn or written here, this would have degree of 2. So we have to up the degree somehow. So there's a bunch of ways you can do this. You could just say, well, let's make that first zero a multiplicity of 2 and the second zero a multiplicity of 2. And then multiply it out. That would work. Or you could say, let's have the first one have a multiplicity of 1, the second one have a multiplicity of 3, and multiply it out. That would also work. But we're going to make it easier on ourselves. The best way to do this for our multiplications would be, let's make the x equals 0 have a multiplicity of 3, and the x minus 3 have a multiplicity of 1, and now the multiplication is going to be very, very simple. So the polynomial would look like this: x to the fourth minus 3x cubed. So that's it. There's the zeros that we need. Now, the only problem is, does this start down? And the answer is no, because it's an even degree polynomial. The leading coefficient test, since 1 is positive here, would say this starts up and it's down. So we have to make the coefficient negative. So it starts down and is down like this. But that's going to screw up our zeros. If you just multiply that first term by -1, that's definitely going to screw up zeros. But if you multiply the whole thing by a constant, it won't. So if you multiply the whole thing by -1, that will not change the zeros. And now we do have one that starts down and has zeros of 0 and 3. And we're just going to do a quick check. I'm going to graph our answer: -x to the fourth, -x to the fourth, and then plus 3x to the third. And we're going to make sure it starts down and it has the two zeros that we're asked for: 0, x equals 0, and x equals 3. So here's the graph. It does start down. There's x equals 0 as our first zero, and the next zero is x equals 3, so that's perfect. That's a good check. We've done it.